Let's try to solve this problem here. We have two properly insulated uniform rods D and E make thermal contact at one end as shown in the figure below. So this is uniform rod D, this is uniform rod E, then they are in thermal contact at this point over here. The cross-sectional areas of both rods are the same. So you can say that you can see that the width or the thickness of these two rods are the same. So therefore we can say that cross-sectional area of rod D is the same as the cross-sectional area of rod E. Okay, then they say that the rods are in steady condition, which means by the temperature along this rod over here will no longer change with time. It has already stabilized right now. Okay, so when we see that these two rods here are properly insulated and they are in steady condition, these two things will tell us something. Okay, insulated plus steady state allows us to know that the dq dt along the rod, okay, the heat transfer, the rate of heat transfer along the rod is constant. Okay, along the rod everywhere you see the same rate of heat transfer happening along the rod. Okay, so now they say determine the temperature gradient along the rod. Temperature gradient is how the temperature varies along the rod. So this is quite a straightforward question. They're asking for how the temperature change dt along the rod dl. Okay, what we can know is that for this situation, because it's insulated and in steady state, our equation dq dt for rod D is equals to negative kd ad and dt over dl for D. Okay, but because we know that it's insulated and in steady state, for rod D, we know that dq over dt will be constant along the rod. It will no longer change. Okay, so it's constant, and we know that K, the thermal conductivity is constant. The cross-sectional area is also constant as well. So from here, we can get we can infer that our temperature gradient should be constant as well. So because the temperature gradient is constant, means by the line is not curved, the line is straight. So if the line is straight, we can change the dt over dl. We can change it to become difference in temperature divided by length. Okay, this is just what it means by changing the differentiation into just a fraction. Because the line is straight, you can do y2 minus y1. Okay, can do T cold minus T hot, then divide by the length over here. Okay, just a rough idea of what I'm trying to say here. So dt over dl for rod D is equals to the difference in temperature for rod D divided by length of D. Okay, so we usually take the difference in temperature to be the right hand side temperature right hand side temperature subtract the left hand side temperature. So for rod D, the right hand side temperature is 80, the left hand side temperature is 100, so it will be 80 minus 100, then divide by the length of the rod or the distance between the two temperature 80 and 100. So the distance between them is 20 cm or 0.20 meter. So if you perform a calculation, you see that the answer here will be equals to negative 100 degrees Celsius per meter. Okay, so what does this value here means? That is that for every meter that we move to the right along this rod, for every meter that we move along to the right for this rod, you will see a decrease in 100 degrees Celsius for its temperature. So it's equivalent to saying for every 1 cm to the right, for every time you move 1 cm to the right, you will see your temperature drop by 1 degree Celsius, because 100 degrees Celsius per 100 cm is the same as 1 degree Celsius per cm. So every 1 cm to the right, your temperature will drop by 1 degree Celsius. Another 1 cm, you drop by another 1 degree Celsius. That's the idea of temperature gradient. It allows you to know how does the temperature varies along the rod. Okay, next, determine the temperature T at the free end of rod E. Okay, you know the temperature at the free end of rod E can be determined through the temperature gradient over here. But how do you relate it with rod D over here? Okay, you know that for insulated case and steady state, because the two rods are insulated and in steady state, the dq over dt should be constant along the whole rod. No matter you are at rod D or rod E, they should all share the same dq over dt. So that means by we can say that the rate of heat transfer dq dt for rod D is equals to the dq dt, the rate of heat transfer for rod E. They have to be constant along the whole rod. Okay, if it's not constant along the whole rod, right, that means some places there will have gain of internal energy or loss of internal energy, which will cause the temperature to change, either increase or decrease, which is what we don't want. Because steady state says that the temperature has already stabilized, so we cannot have any gain or loss of internal energy. So for that to occur, you receive how much energy, you must pass on how much energy. So the rate of heat transfer at every point along the rod should be the same. Okay, so that's why dq dt for D is the same as dq dt for E. So we can expand both sides of the equation by knowing that the rate of heat transfer is negative K A. Then you have your delta T, the difference in temperature for D, divided by the length of D. This is the left hand side. For the right hand side, it will be for rod E, so negative KE, AE, and also the difference in temperature for rod E minus the length of E. Okay, so what we can know from here is that the minus can cancel out and the area can also cancel out because the area are the same. So we can cancel them out. Minus potong, the area also you can cut it off. Okay, next we know that the thermal conductivity for D and E, they have already provided some kind of relationship over here. So the thermal conductivity of rod D is equal to K, whereas the thermal conductivity of E is equal to 2 over 3K. So you can replace that with KD and KE as well. So that is K multiplied by the difference in temperature of rod D. Difference in temperature of rod D, this is rod D, we take the right minus the left. So 80 minus 100. And then you have your difference, then you have the distance between the two temperature, which is 20 cm converted to meter, 0.20 meter. Okay, next you have KE. KE is the thermal conductivity of rod E. Thermal conductivity of rod E is equal to 2 over 3 of K. So this is 2 over 3K. Then you have your difference in temperature for rod E. You take the right minus the left. The right is T, the left is 80. So you take T minus 80 divided by the distance between the two temperature, which is 40 cm. Change to meter will be 0.4. Okay, so again you can see that they share K on the left and right hand side, so K can be crossed off, and now you are left with one unknown, which is the temperature at the right end of rod E. So if you do your calculation carefully using your calculator, key in, solve for X using your calculator, you can get your temperature to be equals to 20 degrees Celsius. Okay, so that means by the colder end or the right end of rod E has a temperature of 20 degrees Celsius. Okay, so I hope everything is clear until now. Okay, so what can we do now is we can proceed to do question C, which asks us to sketch and label a graph to show the variation of the temperature with distance along D and E. So we are going to sketch a position graph to show at every position along the rod what is the temperature of it. Okay, so let's proceed to the next page. So because it's temperature, variation of temperature with position, so I believe the y-axis here should be temperature, which is in degrees Celsius, and the x-axis will show the position along the rod. So this will be x in the unit of meter. So your rod here, you can label this is D, this is E, this is a composite rod of D and E. Let's figure it. Split the 3, so D will be around here, E will be around here. So know that the length over here is 0.2 meter. Then you know the length over here is 0.4 meter. So from here, if you take here to be 0, then here will be 0.20 meter. Whereas here, if you measure from the start to the end, the distance will be 0.20 plus 0.40, which is 0.60 over here. So you have already labeled the x-axis, the position where you know the temperature. Okay, you have 3 positions where you know the temperature, 100, 80 and 20, which is 0, 20 cm and 60 cm from the origin. Okay, next let's label the temperature. You know it's 100, 80 and also 20. Okay, 20 is what we determine from B. Okay, so you know it happens on a scale of increment of 20. So let's draw 5 line, 20, 40, 60, 80 and 100. So you can label here to be 20, 40 and 60 don't need to label, then followed by 80 and 100. Okay, so you know 100 is the temperature at the left end of D. So left end of D is over here, so you can straight label here to be 100. Okay, 100 is over here. Next, you know that 20 cm from the left end, 20 cm from the left end, the temperature is 80. So from here, pull upwards, you should get 80. Okay, so let's dot 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 dot. Okay, dot 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 dot. Okay, 80 will be around here. Then continue for 20 degrees Celsius. It happens at the left end. Left end is 60 cm to the left, to the right. So 60 cm to the right is somewhere around here. So you pull upwards. Then you pull over here, 20 degrees Celsius. Then this is the point over here. Okay, so from here you can draw 2 lines to connect between these 3 dots over here. What you need to do is just connect the dots only. But make sure, because just now I already mentioned that it's insulated, at the same time it's in steady condition. That means by your dt over dl is constant along the rod. Along each rod actually. Okay, so because it's constant along each rod, you should expect a linear line. Okay, if it's not insulated, then heat will release to the surrounding, then it will not be a linear line. But for now, because because the rod is insulated, no heat is released to the surrounding. Heat will be passed along the rod without any escape, heat escape. So in that case, you should expect a linear line for your temperature graph. So it'll be straight to this point, followed by another straight to this point. Not very well drawn. Let's try again. Okay, something like this. Okay, so you label clearly your temperature on the y-axis, your position at the x-axis, then you just make sure that whether it's insulated or not insulated. If it's insulated, connect the dots with straight line. If it's not insulated, you have to go slightly below the temperature of the insulated rod, which is slightly lower. Okay, so this is a temperature graph to show the variation of temperature with distance along rod D and rod E. Make sure 3 temperatures are there and 3 different distances are there, then you are good to go. So that's it for this question over here.